Hi guys, we're back and we're going to be talking about how to use soeing PCR in order to build libraries. Soeing PCR is a great tool for putting degenerate base pairs into your DNA, and let's talk a little bit about how that works. So we're going to say that we have some sort of an open reading frame, some sort of a protein, and that we know that this is where the active site is. So our challenge is to go from a DNA sequence, a wild-type DNA sequence that has that sequence, to a piece of DNA that has a bunch of ends in it. And instead of writing a bunch of ends, because that's a huge headache for me, we're going to say X. So we're going to go from just a regular wild-type gene to X, and then X, for our purposes, will equal 5 n's, so n times 5. So what we're going to be doing is we're going to be running our two initial PCRs. So we're going to have our forward primer binding to the 3' of our template. And we're going to be having our reverse primer binding over the region that we want to mutate. And this primer is going to be broken into 3 different sections. So let's cordon those off right now. Section 1, 2, and 3. Section 1 is going to be used for this initial PCR reaction. So here's section 1. Section 2 is going to be used for introducing our mutations. And section 3 will be used for the soeing, for the actual splicing. It's going to be used for that overlap extension reaction. So let's draw in our 5' and 3' on our DNA. So when we run this PCR, our primer is going to actually bind here, and we're going to get a little bit of binding there, and we're going to get this X. This is the oligo that is introducing those ends. And we're going to extend here. Let's draw our extension into yellow. So we're going to extend up until here. And this oligo is going to do the same thing, and we're going to be extending over the reverse oligo. And I should probably be titling these. So we're going to have oligo 1F and oligo 1R. So the product of this PCR reaction is going to be a chunk of DNA from the 5' of the reverse oligo over. So I'll draw that out right now. So we're going to get this. And we can kind of map the sections of that oligo, that special oligo, that reverse oligo, onto that chunk of DNA. So this chunk of DNA from this PCR reaction is now going to include a bunch of ends, represented by the X. And this was the homology region of our oligo in order to generate this. So the oligo bound to this region. So we can remember the oligo bound to this section of DNA in order to create this whole chunk, and then the forward oligo is just here. So if we just draw in there, there's our forward, and then a reverse would have been something like that. Hopefully you can see that. So when this reverse oligo bound to this area in order to create this chunk, it brought along all of the mutations as well as this other homology region. But this section 1 right here was the only section that was involved in running this PCR. And we just tagged on these additional 2 sections for later in this procedure, or later in this reaction. So section 2 is the point of why we're doing this. Section 2 is where we're adding the mutations. Section 3 again is for this second round. So this is one half of it. We also have the other PCR, the other first PCR. So we are running 2 PCR reactions in order to generate our 2 fragments. So I'm going to say we have another forward oligo in order to introduce mutations up here, and reverse oligo. And just like our reverse oligo down here, this oligo is also broken down into 3 sections. And before I go any further, I'm going to name them. This is going to be 2F. And this is going to be oligo number 2R. So like oligo 1R down here, oligo 2F also has 3 sections. So we're going to say section 1, 2, and 3. Section 1 has homology to the template DNA. This homology is what's going to drive this PCR reaction. If we just ignore sections 2 and 3, and we only had an oligo that consisted of section 1 right here, then we would just get a PCR chunk that, just a normal PCR chunk. But oligo 2F is bringing along sections 2 and 3. It's bringing those 2 sections along for the ride. So they're gonna be there no matter what. So section 1 binds to the template. Section 2 is coming along for the ride, and it is going to put in an X. It's going to bring along those mutations. So it's going to put in those 5 N's, represented by X here. The drawing is starting to get ugly. And section 3 is another homology region, but section 3 doesn't really play any role here quite yet. Section 3 doesn't have any functional role for this first round PCR. It's going to be used in the second round of PCR in the actual soeing PCR. So let's draw out what the products of this second reaction looks like. So we're going to be starting from around here. So from the 5' of oligo 2F all the way to the 5' of oligo 2R. And I should be labeling everything. So 5, 3, 5, 3, 3, 5. Now, just like we did for that first chunk, let's kind of map our oligos on. So if we think about our oligo 2F, these are oligos 2F and 2R made this chunk, and we can kind of map the sections onto it if we break this up. So we have section 1 of oligo 2F, which is going to be right here. This is where our oligo bound in order to run this PCR reaction. Section 2, this is what created our mutations. And then section 3 was just another homology arm, which does not really matter for this PCR reaction, for this initial PCR reaction. But we're going to see in a little while why it matters for the actual soeing. So I'm going to label this. We're going to go back to our first reaction. I'm going to label this. So we have section 1, section 2, and then section 3. So now we have our 2 fragments. We've run 2 individual PCR reactions. So this is, reaction 1. And here's reaction 2. These are in 2 different tubes. And then we clean them up. We maybe run them on a gel, make sure everything looks good, everything's the right size. We have single bands. We have a lot of DNA. We purify them off of our gel. And then we're going to start the soeing reaction. So this was step 1, I would say. This is part 1 of using soeing in order to make a library. And I'm looking at my time right now, and we're going to make a cut point, and we'll be right back just so we can fit this on YouTube. So be right back.